When I reoriented my triangles here, I ended up with the triangles looking like these top ones instead. So when I reoriented my triangle, I ended up with my slope angle here, which meant that this was my delta y and this was my delta x for the 22-degree angle. And here, my slope angle was 18 degrees, and that made delta y the side length that's labeled with x, and delta x the side length that's labeled with 15. But I don't want to have to reorient my triangles every single time I'm dealing with one of these. So I need to figure out, is there an easier way to figure out which side length is the delta y and which side length is the delta x? Well, I want you guys to look at this and see if you notice a pattern of where the delta y is relative to the angle and where the delta x is relative to the angle. And then if we're looking at a triangle that is not reoriented perfectly, how can I figure out which side is the delta y and which side is the delta x? I want you guys to take a look at this and think for a minute and see if you can figure out the pattern. How am I going to be able to tell which one is the delta y and which one is the delta x when my triangle is not oriented perfectly to be a sloped triangle? So take a look and see if you can figure out which one is delta y and which one is delta x. What I notice here is that my delta y was always the leg that was directly across from my reference angle, the angle that I have marked. So if I am looking at this 18-degree angle down here, my delta y is going to be the side length that is across from it. So that means that the 4 is the delta y. And if I'm looking at my delta x, it is always the leg that is next to my reference angle. So in the case of this 18-degree triangle, A would be my delta x. So if I wanted to write out my slope ratio for this triangle, I would have 4 over A. That would be the slope ratio for that triangle. All right, so what I want to do now, though, is I want to kind of generalize this so that we don't have to worry about trying to reorient and that we can just kind of use this generalization. So here is my generalization. In a right triangle, you will always have the hypotenuse, which is directly across from the 90-degree angle, and then you will have 2 legs. And the legs are the sides that create the 90-degree angle. Your reference angle is going to be whatever angle you have marked. In this case, it's 18 degrees, but we can kind of generalize it by calling it theta. And from your reference angle, you're going to have an opposite leg and an adjacent leg. And rather than thinking of our slope ratio as being delta y over delta x, now I want you guys to start thinking of it as the opposite leg divided by the adjacent leg, or the opposite leg over the adjacent leg. And here's a little vocabulary for you. Opposite means across from, and adjacent means next to. So no matter how my triangle is oriented, I can start by picking what my reference angle is, and then from that reference angle, label the opposite leg and the adjacent leg. And then instead of doing delta y over delta x, I will do opposite over adjacent. Now I'm going to use this idea of opposite and adjacent legs to help me figure out what the ratios would be for this triangle. So first, it says find the slope ratio of 32 degrees. So I'm going to mark 32 degrees as my reference angle. So that right there is the reference angle. 9.434, that's my hypotenuse, so I don't need to worry about that guy at all. But from my reference angle, 5 would be the opposite leg, and 8 would be the adjacent leg. So my slope ratio is always now going to be opposite over adjacent, which would be 5 over 8. 5 over 8. I'm going to find out what that is in decimal form as well. Oops. So 5 divided by 8 is 0.625. So the slope ratio for 32 degrees should be 5/8 or 0.625. All right, the next question says find the slope ratio of 58 degrees. 58 degrees is this reference angle. So that means that now my opposite and adjacent are going to switch. And this is going to be my opposite leg. And this is going to be my adjacent leg. So to find the slope ratio for 58 degrees, I'm going to have 8/5. And in my calculator, I've got 8/5 is 1.6. So remember, we talked last week about how in a right triangle, the acute angles are complementary, they add up to 90, and their slope ratios are reciprocals. So 5/8, 8/5. And here's why they're reciprocals. Because when you come from a different reference angle, your opposite leg will become the adjacent leg and vice versa. So if I'm doing opposite leg over adjacent leg, I'm going to get my slope ratio. So far we've been using slope to determine these ratios, but now we're going to kind of take it away from slope and we're going to get more accurate with our answers. And these slope ratios are going to be what we call our tangent ratio. And our tangent ratio is our start of trigonometry. So tangent ratios are going to be more accurate than just finding the slope ratios that we have, and they're going to be something that we find in our calculator.